This is 3.6 rational functions. This is part 2 of the video, so if you have not watched part 1, make sure you go back and watch part 1. So I'm just going to continue talking about finding the vertical and horizontal asymptotes of this function, and then domain, range, and graphing the function. So on this particular problem, this is talking about the vertical and horizontal asymptotes. So if you look back at the previous page, what we did, again, go back and look at the video that we did, but you notice we can find the horizontal asymptotes and the vertical asymptotes by 2 things. First of all, the vertical asymptotes. So the vertical asymptotes can be found when you look at the denominator and find out what x cannot equal. So if you look at this denominator, 2x squared plus 3x minus 2, and you want to find out when it can't equal 0. So we're going to basically factor this and find out what it can't equal. So notice this factors to 2x minus 1 and x plus 2, which means at negative or positive 1/2 and negative 2. So x cannot equal those two. So if I ask to graph this one, this actually has 2 vertical asymptotes. So x cannot equal 1/2 and x cannot equal negative 2 because those are both on the denominator. So this literally has like a vertical asymptote and a vertical asymptote at both of those. And again, if we graph this, you would have to pay attention to where, as x approaches negative 2, as x gets away from negative 2, as x approaches 1/2, as x gets away from 1/2. And you'd have to make a pretty big XY chart to consider all of the possibilities, what is happening to the function. Now, to find the horizontal asymptote, so if you go back and look at it, so notice the exponents on, and this all has to do with the horizontal asymptotes right here. So the horizontal asymptote, so if n equals m, and that's what we have on this scenario, so if the exponents equal one another, if they equal one another, then the horizontal asymptote is literally a divided by b. So the coefficients a divided by b. So the horizontal asymptote y equals 3/2. This is what y cannot equal. Y cannot equal 3/2. So on a piece of graph paper, it can't equal. We already said at 1/2. So 1/2 is the vertical asymptote, and negative 2 is a vertical asymptote. But you also have a horizontal asymptote at 1.5. So then after that, if I ask you to graph it, you'd have to, find out what that function looks like as x approaches negative 2. As x approaches negative 2, what's happening to the function? And you can see that it's going to look like this. And then consider what's happening in between those 2 vertical asymptotes. So as x gets away from negative 2, so negative 1.5, negative 1.2, negative 1/2, 0, 1, or not 1, but as it gets closer and closer to the other vertical asymptote, which is 1/2, what's happening to the function? And you can see that this function inside of those asymptotes is going to look like this right here. And then same thing as you graph this, it's going to look like that. So as you graph that, you can see all those possibilities. So you just have to plug in a bunch of numbers to kind of generally, and really just 2 or 3 numbers on this side of the asymptote, 2 or 3 numbers over here, 2 or 3 numbers over here, and you should be able to figure out what the graph's going to look like. Is once you found the vertical asymptotes and the horizontal asymptotes. So the idea, the plan of attack for graphing, first factor the numerator and denominator. So that will help you find any possible zeros, what x cannot equal, and so your vertical asymptotes and horizontal asymptotes. Finding the intercepts is going to be very helpful as well, finding the x-intercepts. And then the vertical asymptotes, we said that at the very beginning, you look at the denominator, what x cannot equal, and then as x gets away from that, and as x approaches that, and the same thing, what's happening specifically to the horizontal asymptote, make sure that you're not, the horizontal asymptote is going to be very important when you get closer and closer to that, the horizontal. And then you actually sketch the graph. So that's the plan of attack. So let's actually tackle one problem and make sure we understand how to do this problem from the beginning to the end. So notice this function here. I have a function that has, we're going to have to consider the denominator and the numerator, and consider the x-intercepts, and also consider the asymptotes, both horizontal and vertical asymptotes. So if we factor the denominator, notice the denominator is going to be x plus 2 and x minus 1. And that tells us immediately that x cannot equal negative 2 and cannot equal 1, which tells me there's a vertical asymptote at negative 1 or negative 2 and a vertical asymptote at 1. So we're going to have to consider what happens as x gets away from 1. So as it gets to 1.1, 1.2, 2, 2. What's happening as x gets closer and closer and closer, or I mean further and further away from 2 and from 1, and also as it gets really close to 1, like 1.1, 1.01. I mean, what's happening when it gets close to that? And then we got to consider what's happening to x as it in the middle of this. What's happening to the function as x is 0 and in between 1 and negative 2, and then the same thing, we're going to consider all the x's, what's happening as x gets further and further away from negative 2, and as it gets really, really close to negative 2 as well. We're going to consider all that. So let me erase all those, and let's consider some things as well. Let's find the horizontal asymptote. Well, notice the horizontal asymptote has the exponents are the same again, and so which that means all we have to do is we're going to look at the coefficients divided by one another. So 2 divided by 1, which is 2. So we know that there is a horizontal asymptote at 2. All right, so that's something to consider. So y cannot equal 2, cannot equal 2. So now we know what the domain and the range are, by the way. So it's all the x's except for these two guys, and it's all the y's except cannot equal 2 for the range. All right, so now what we're going to do is just consider, again, think of the XY chart. I would make an XY chart, what's going away from one of these asymptotes and getting closer and closer to the asymptotes, finding out which direction it's going to go. So let's first consider, let's think of the XY chart, and let's first consider this asymptote right here, x equals 1. So, if I started plugging in 2, I want to find out what's happening, where is the function at 2. So if I started plugging 2 in, I'm going to find a certain value, and then really what you need to do is after that, once you plug in 2, you're going to see where the function is, and then I would plug in like one more number, and if you plug in, like you could plug in 1.5, or you can plug in 3, and that way it tells you which way the function is going, and you're going to end up graphing this function. You're going to see that it's going to look like this. So really all you have to do is plug in maybe 2 numbers, and you can see where the function's actually going in that little section to the right of the asymptote. Now, and then the same thing if I started plugging in numbers this direction. So look at negative 2. So if I plugged in negative 3 and then negative 4, or you could plug in like negative 2.5 and find out what's happening to the function in that scenario. So again, negative 2.5 and negative 3, negative 4. So you don't need all those numbers, but just plug in some numbers and you'll be able to see what the function's looking like. So it's looking like this. Now, the part in the middle is, again, you need to pay attention to as well. So if you plug in 0, 0 is a very nice number to plug in. So if you plug in 0, you can see that you're going to get 2. You plug in like negative 1. So you're plugging in numbers in between here. Let me switch to purple. So if you're plugging in numbers in between here, you can kind of see what's going to happen to the function as well. So it's going to look like this. So as x gets closer and closer and closer to negative 2, it's going to be really, really high. As x gets closer and closer to 1, it's going to get really, really negative. To be able to do that. So the function is going to look just like that, and we already talked about the domain and the range. So that's how you graph rational functions, and considering what the domain and the range are, and where the vertical asymptotes and the horizontal asymptotes are.